Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8, want to present about the data set of New York State index crime by using the agglomerative hierarchical clustering. For introduction, we have choose the data set from New York State. In this state, there are bundle of cases has been reported under Division of Criminal Justice Services. The crime that have been recorded include violence crime of murder or non-negligent manslaughter, forcible rape, robbery, and aggravated assault, and property of burglary, larceny, and motor vehicle theft. For this project, we will use the agglomerative hierarchical clustering to rearrange and clarify which area in New York State has the highest number of criminals in each crime. For the problem statement, a lot of crime happen in New York State, and the big problem is the processing of large amount of data. The data that have been recorded are so messy for the users to read. By analyzing the data using machine learning and identifying a pattern, we can help the police in making the decision faster. And there are also many cases to handle in some states that have a high number of crimes, while the police officer facing short-handed in that state. In this project, our objective are to process and analyze the state crime dataset using the preferred model, to develop an algorithm using agglomerative hierarchical clustering to get significant information from the New York State crime dataset, and also to analyze the result using the algorithm based on the developed model.
The algorithm we are using for this project is agglomerative hierarchical clustering, which is also called bottom-up clustering. In this example, we can see that we have 8 data points. Each data point is considered as a single cluster in the beginning. We calculate the proximity of individual data points at the beginning. Then we merge two cluster or two data point together based on the similarity of the nearest clusters. So as G and F data point has similarity, we merge it together and we get a cluster FG. Then we have similarity between cluster E and cluster D. So it merged together and we get a cluster which is DE. And then we are left with clusters H, FG, DE, BC, and A. And then we calculate the proximity again for each clusters, which are H, FG, DE, BC, and A. Then we calculate the similarity of two clusters again. So between DE and BC there is similarity, so it makes one cluster which is BCDE. Between H and FG it has similarity and it merges together and makes a cluster FGH. And we are now left with three clusters FGH, BCDE, and also A. Then we again calculate the proximity and then we calculate the similarity. So between FGH, BCDE, and E and A, we have similarity of data points A and cluster BCDE. So this both merges together and makes a cluster ABCDE. Now we are left with clusters FGH, ABCDE. And then we calculate the proximity again. Now we have only two clusters which merges together and the final cluster is ABCDE FGH. So based on this example, we can understand that we only stop when we have only one cluster. From this GIF, we can see that how agglomerative hierarchical clustering actually works and how it pairs up and then makes a whole cluster. The advantages of agglomerative hierarchical clustering are No prior information about the number of clusters are required. It can produce an ordering of the objects which may be informative for data display. Similar clusters are generated which may be helpful for discovery, easy to implement, and gives the best result in some cases.
Assalamualaikum warahmatullahi wabarakatuh. My name is Liyana. Okay, I will continue our presentation with the dataset description. Okay, our dataset is about the New York State Index Crime, which we carried from the Kaggle. Okay, I will tell you a little bit of the introductions about our dataset, which is the Divisions of Criminal Justice Service collects crime reports from more than 500 New York State's police and sheriff department. These criminal divisions use this report as New York's official crime statistics and submit them to the FBI under the National Uniform Crime Reporting Program. Okay, so now let's go to our data. I will tell you what we have in our column one by one. The first one is the county. County is the location where the crime was reported. Okay, we can see we has Dutchess, Steuben, Nassau, Erie, and something else small down there. And then we have agency. Agency is the police department that reported the crime. Okay, and then we have year. Year is, it is obvious, right? The year of the crime incident was reported. And then we have months reported. Months reported is the number of months, and individual agency reported of the year. Okay, then next one we have index total. Index total is the sum of murder, rape, robbery, aggravated assault, burglary, larceny, and motor vehicle theft. Okay, the next one is violent total. Violent total is the subtotal, includes murder, rape, robbery, and aggravated assault. All of these four columns is the violent total. And then next we have property total. Property total is the subtotal, includes burglary, this one, larceny, and motor vehicle theft. It is obvious, right? Because it is their property. And then the last one is the region. Region is where the crime was reported. Region include New York City, such as Bronx, King, New York, Queens, and then whether it is in New York City or not. Okay, our data, the total, you can see right here, the total of our data is 1900,000. 19, okay, 1900,000. Okay, it is a lot of data, but you can also see right here there's a lot of null, empty space right here. We can see this. So we have to do data cleaning, so on and so forth. After that, we kind of have a little bit lesser data so that we can proceed for our EDA, for our data visualizations, for testing, and what else something. And okay, that's all from me. Thank you.
Assalamu alaikum. My name is Hafsa Yasin. I will be explaining about the data pre-processing stage. So first of all, data pre-processing helps us identify and remove missing values or outliers. Now for our data set, which is the New York State Crime data set, it comprises of around 19,325 rows and 15 columns. Being a very large data set, we will have to undergo through data pre-processing in order to remove any missing values. So the first step is to import the data set. For this part, I will be using Microsoft Azure Notebooks. Then I created a folder and named it dataset, and then I proceeded to upload our dataset. So here we can see the dataset and the file nyc.csv. saved into a new variable known as NYC. The next step is to take care of the missing data, which will be explained in the next slide. In this slide, we can see the first line is the dataset being read using the command for the function read.csv. We then proceeded to check the structure using the str function. Structure enables us to observe our rows and columns. Here we can see we have about 19,325 observations as well as 15 variables. Then we proceeded to check whether we have missing values using the is.na, NA here meaning not applicable. If there are values that are not applicable, the value will be reported as true. If the values are there, it will be reported as false. Seeing from this data set that we have values reported as true, it shows that we have missing data values in our data set. We could also use glimpse, which works the same way as str, except that in glimpse, it helps us identify larger data or more data compared to str. So same thing here, it shows us the rows and columns as well as the data types. Now moving on to cleaning the values that are missing, we will use the complete.cases function. Complete.cases enables us to identify complete rows and automatically removes rows with missing values. We then proceed to save this data in a new variable known as clean data. We will yet again use the glimpse function in order to check if our missing values have been removed from the data set. Here we can see that the number of rows are 9,600, which is a drop from the 19,000 rows, and the columns remain the same. So this shows that our missing values have been successfully removed. Now that the data is clean, we will proceed with data visualization, which will be explained by my fellow teammates.
For data visualization, we can see here is the subset from the data that we have. This is the index crimes from 2002 until 2017. This is the line graph of it. We can see from the year of 2002 until 2011, there was a slight decrease in the graph. But in the year of 2012, the graph seems to be sharp increase, and it actually achieved more than 450,000 of index total of all the crimes that actually gathered in that year. But it actually gradually decreased after that year until 2017. Other than that, we have the data visualization that actually we can see that different countries have difference of index total. It means that the total index of crimes actually happened, actually being reported in that state in New York City. This is the graph. The bar chart for the total index for each of the states in New York City. We can see that it actually from all of these data, we can see the state of Erie has achieved almost 500,000 of index total crimes being reported or recorded throughout the years from 2002 until 2017. We can actually see there was a small amount of index crimes actually being reported in Hamilton, maybe about not more than 50,000, I guess. But we can see it from the table here. This is the subset from all the data that we have. So basically, we can see which states record the highest amount of index crimes throughout the years from 2002 until 2017, in each state has the minimum number of crimes being reported or recorded throughout the years.